In this video, I will introduce you to the concept of a regression line, how to draw the line on a scatter plot, and how to determine the equation of the line. A regression line, also called a line of best fit, is a straight line that is the best approximation of a given set of data. A regression line is used to study the nature of the relationship between two variables. So, for example, on our scatter plot, if variables x on the independent variable x and the dependent variable y are plotted on a scatter plot, then we draw a straight line through the data. The upward sloping line, this here is our regression line, and because it's upward sloping, we can say that the variables x and y are positively related. And then, depending on how close these points are to the line, that will tell us the strength of the relationship, which in the earlier video we quantified using the correlation coefficient. If, on the other hand, the two variables x and y can be modeled using a downward sloping regression line, then we know that x and y are negatively related. There are several methods that we can use to draw a line of best fit or a regression line onto our scatter plot. And one of these methods is called the eyeball method. And to use this method, the straight line is drawn on the scatter plot such that, and these are the conditions for using the eyeball method. The first one is that the line passes through as much points as possible. And the second one is that the number of points above and below the line is just about equal. What this means is that the regression line may pass through all of the points, some of the points, or no points at all. I'll demonstrate using an example. The mass y grams of a chemical is related to time x minutes for which the chemical reaction has been taking place according to the table. So in this table, when the time is 5 minutes, the mass of the chemical is 4 grams. When the time is 16 minutes, the mass of the chemical is 21 grams. The question is, plot a scatter diagram and draw an estimated regression line for the data. So we set up our axis. Notice that we label our x-axis time, since that would be our independent variable, and we label our y-axis mass, since that is our dependent variable. And according to our table, we have to plot the point 5, 4. The point has coordinates, x coordinate 5, so 5 on the x-axis, 4 on the y-axis, so that's that point. Next is 7, 12, so 7 on the x-axis, 12 on the y-axis. Then 12, 18, So 12 on the x-axis, 18 on the y-axis, 16, 21, 16 on x, 21 on y, that's about here, and finally 20, 24, 20 on the x and 24 on the y. At first glance, our variables appear to be positively related, and we can see that this is evident from our table. Notice that as the time increases, as the duration increases from 5 to 7 to 12 to 16 to 20 minutes, the mass of the chemical also increases. So this is an indication that these two variables, mass and time, are directly related to each other. Now we will use the eyeball method to draw the line of best fit. And there are several ways in which we may attempt to do this, but only one correct way of actually drawing the line. And that makes the eyeball method one of the least reliable methods to use. Now recall the conditions again. For us to use the eyeball method, the line must pass through as much points as possible, and the number of points above and below the line is just about equal. So what I'll do is I'm just going to make a guess here and say that the regression line looks like this. That is possibly the regression line, or I can draw it differently. I can choose to draw it like this, and that could possibly be our regression line as well. So this one could be the regression line, this one could be the regression line, or it may be the case that neither one is the regression line.